Hello everyone, we will solve this today's LeetCode problem. So after a very long time, long break actually, so we will start daily problems from now. So this is the find the student that will replace the chalk. That's the question. Let's see what it is asking. So there are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then student number, and so until the teacher reach the student n minus 1, right? After that, teacher will restart the process and starting with the student number 0 again. You are given a zero indexed array, chalk and integer k. There are initially k pieces of chalk. When the student number I is given to a problem, they will use a chalk I to solve that problem, right? So basically, and then student number of I is asked to replace that chalk if it is strictly less than uh, the available chalk, right? Also, we need to return the index of the student that will replace the chalk I pieces. So basically the question is just to return the index when this chalk I is less than the current remaining chalk pieces, right? That's the question. Let me explain the first example. You will be better understand that what is the question asking. So basically the first time, let's take this explanation, uh, right? So basically what is happening that teacher will uh, give the questions in sequence wise, student number 0, then 1, then 2. That's how the teacher will distribute assign the question numbers to the students, and they will use this much amount of chalk to solve that particular problem, right? So the first number student assign the question, so it need to use 5 chalk to solve that problem. So if he use 5 chalk, that the remaining remaining chalks will be 70, right? Then we will go to student number 1. It will take 1 chalk to solve that problem, so that will be k is equal to 60. Now student number 2, it will use 5 chalk. Now k becomes 11, right? Now k becomes 11 after student 2. So it will repeat the same process, right? Now again teacher goes to 0th student and the assign the question to them. So we will check that whether this 5 is greater than this 11 or not. Yes, this is greater than, it means he can solve the question. So basically it will use 5 chalk, remaining will be 6. Same for 1, it will can use 1 chalk, remaining will 5. The last student must have to use 5 chalk to solve the problem, and we have left 5 chalk, so he can use, so he or she can use. So it will remaining, now k is equals to 0, right? After that, when teacher assign again the problem to student number 0, which wants 5 chalks to solve that problem, it doesn't have, right? It has 0 number of chalks and it need 5 number of chalks. So it means now we got the index of the student that will replace the chalk pieces, which is 0. That's why the answer is 0, right? That's the whole explanation for this problem, right? So basically, how we will find the index of the student that will replace the chalk pieces? The first thing is that you will uh, do the same thing, which is asking the question that you will go to 0, then 1, then 2, then again 0, then 1, then 2. But if you see the constraints here, k is 10 to the power 9, right? K is 10 to the power 9, which is very much, and n is 10 to the power 5, right? And if you do, if suppose it takes 111 chalk to 10 to the power 5 till, and k is equals to 10 to the power 9, it means you need to trade till 10 to the power 9, right? It will minimum 10 to the power 9, right? If every student needs one chalk and k is equals to 10 to the power 9, so that will give definitely clearly that, then it means you cannot simply use a brute force approach, that you can't iterate for each student again and again, again. You need to do something so that it will not reduce, it will not move till o of k. It should can max go to o of n, right? Okay. One thing you note here, that we are subtracting the number of chalks which student wants, and at last I am seeing that whether we have, and checking that whether we have the chalks remaining, the chalks remaining with me or not, so that a student can use for solving that question, right? That's what the conclusion is, right? So can we simply use some mathematics, some maths, to reduce this problem, reduce this problem, reduce the problem of not iterating to all the students each and every time, right? Each and every time, because we can't iterate, right? The problem is that we can't iterate to each and every students multiple times and reduce the chalks each and every time whenever it get used, right? That's the problem. So can we use this? So one thing you observe here, this is the same repeating process, right? 0 1 2, again 0 1 2. So basically what is happening, see, the number of chalks can we simply divide it, can we simply divide it. See what I am saying that sum of chalks, what it would be, if I just take sum of chalks, that would be 5 5 10 plus 11, right? And there are number of chalks is 22. So how many times the whole student can use, can solve the problem? So that would be definitely 22 by the k divided by sum of chalks, right? Sum of chalks, that would be the number of times the whole total students can solve the problem, can solve the problem, right? Without any worry, k divided by sum of chalks, right? And how many students can be, how many students after solving all the problems, how many students can be, how many chalks would remain? That would be remainders, right? That would be remaining number of chalks, remaining number of chalks, and that would be k modulus, right? K modulus sum of chalks, sum of chalks, right? In sum of stocks for students, right? Sum of stocks for students. So that, this is the number of times total students can solve the problem. So this much amount of iteration reduced, right? This much amount of reduced, right? Iteration introduced. And we know that when we do k modulus sum of chalks, it will definitely be less than k, right? It will definitely be less than k, right? It will be definitely less than sum of chalks, right? I'm sure about that, right? So basically what will be happening, that we will just solve for this, right? We will just solve for this. So basically, if suppose we take this example, suppose we take this example. So here 3 4 1 2, the sum is 7 plus 1 8 and 10, right? So how many times the whole students can solve solve the problems in this amount of chalks? So that would be, count is, number of times is, number of times is, that would be k by sum, and that would be 25 by 10, which is 2. And how many number of chalks remaining chalks would be k modulus sum, right? After iteration of 2, 3 4 1 2, again 3 4 1 2, how many how many times, how many number of chalks will remain? 5 number of remaining. How this is calculated? 25 modulus 10, which is 5, right? 5 number of chalks will be remaining after iteration, after whole two type of iteration, right? So it means I just need to focus on 5, right? Now now k becomes 5. I need to focus on that, and this chalk, right? Now I can iterate in whole chalk to see that at which index this 5 is greater than the chalk I, right? So I will iterate from 0. So this is 0, which is 3. 5 is greater than 3. It can iterate. So 5 now becomes 2. I will now go to 4. This 2 is less than 4, right? So this student cannot solve this problem. So 4 is greater than this 2. It means the index will be 1. The student will be replace the chalk I, which is the answer, right? So basically, ultimately, what we need to do, we just need to focus on sum, then remaining number of chalks, and what it would be the k modulus sum. That would be the remainder number of chalks after iterations, right? And now we will focus on this remaining number of chalks instead of this k, right? And we will iterate once a time to check whether which is greater than at which index, right? That's the whole point of this question, right? Hope this is an easy question, right? So we will just solve this. Let's just solve this. this chalk dot size. One thing, if you note here, if you see here the constants properly, the n is 10 to the power 5 and chalk I is also 10 to the power 5. So when you do the summation, this can go to 10 to the power 10, which is out of one for int, right? So we need to take long for summation, right? To so that it does not give runtime error, right? So we will just calculate the summation for that, sum plus x, right? And now what we need to do, we need to calculate the remaining number of chalks, which will be int remain the k modulus sum. We don't need to count because the count is not used. We just need to use the remainder, how many remaining number of chalks will be left after whole iteration, right? So now we will just calculate the index. We will start iterating in whole chalk and check whether this rem is, if it is less than the chalk I, it means this will be the index which we need to return, right? Because the chalk I is, if it is greater than this remaining number of chalks, it cannot solve problem, right? Otherwise we will just subtract from remaining number of chalk I and at last return -1, right? So let's run this. It passed. Let's submit it. Yeah, we have successfully passed all the test cases, right? So basically that's the same, that's the whole problem, that's the mathematical thing, this one, right? That's the whole problem. It is an easy problem, but yeah, let's take it a medium one, right? So what is the time and the space complexity? So if you see, we are just iterating one time here and one time here, right? So that would be O of n plus O of n. Ultimately it is O of n. And the space complexity is, so we haven't taken any extra spaces, right? Only the summation and that's variable, so that would be O of 1. So that's the whole uh, time the space complexity for this problem. Hope you understand it, and sorry for being taking a long break. I was not well, uh, so yeah. So now we will continue from that here. Thank you so